Kia ora, Year 12. This is a differential equations question from the test that I gave you a week ago. It's also a good one for level 3 integration. So it's a pretty standard question, only we don't have any specific values. So reading it slowly, we've got compressed air escaping from a container, and the pressure of the air in the container at time T is P. The constant atmospheric pressure of the air outside the container is A. So it's important to note that that's not a variable, right? The variable is going to be P, and the rate of decrease is proportional to the square root of the pressure difference. So they've very kindly written the DE for you, but you would be able to do that, right? Because we've got our constant of proportionality K, and then we've got the square root of P minus A. So you pretty much know what you've got to do before you even start reading the question. First, we're going to find a general solution to this differential equation. In other words, we want to find an expression that links P and A and hasn't got any derivatives in it. Then we're going to substitute in a couple of specific things. So first of all, we've got an initial condition that when it's the start, T equals 0, the pressure is equal to 5 times the outside atmospheric pressure, and then we've got this condition after 2 seconds. Next we have to figure out when the pressure in the container is equal to the pressure outside the container. And lastly, we have to get an expression for P in terms of A and T. So I don't think this is as hard as the integration question, but I'm going to go through it quite slowly because in the test a lot of you found this tricky. I've just posted 10 questions on Google Classroom for some DE practice from Dr. Frost. So go do these when you finish this, if you've still got an appetite for DEs. So let's start by looking at what we've got. We've got dP by dt is equal to negative k times the square root of this. So straight away we know we've got to separate the variables, remembering that a is a constant. So we're going to have 1 over root p minus a is equal to negative k, so dp here is equal to negative k dt. And we're going to integrate both sides. I'm going to rewrite the left-hand side here with a negative fractional power so that I can see what to do. And on this side I'm going to get negative kt plus c. So that's our usual setup for the right-hand side. Now integrating this gives me p minus a to the power of a half times 2, right? So I need to have the times 2 because when I differentiate this, this half is going to come down the front and it has to have the times 2 to undo its impact. So that's what we've got here, and we've done the right hand side integration already. Okay, so what were we asked to do? Well, the first part was just to find in any form the general solution of this differential equation. So that's fine, that's all we had to do. We don't have to clean it up too much. We could write it like this. But I think that would have been enough. Okay, now we've got 2 conditions. We've got when t equals 0, p equals 5a, and when t equals 2, p equals 2a. So we're going to substitute into here both of those. So we've got 2 times 5a take away a to the power of a half is equal to 0 plus c. 2 root 4a is equal to c. So this is 2 times 2, so 4 root a is equal to c. We can take this and now substitute it into this. So root p minus a is equal to, what have we got? Let's see, well, we've got negative kt plus that constant, which is 4 root a. So now we've got this, and we're going to use this condition to figure out the value of k. When t is equal to 2, p is equal to 2a. So in here, 2 2a take away a is equal to negative 2k plus 4 root a. Root a is equal to negative 2k plus 4 root a. Oops, something's gone wrong in here. Sorry, we've lost a 2 here. That should have, yep, it should be 2 root p minus a. That's better. Okay, so just cleaning that up, what am I left with? Well, I've got 2k is equal to 2 root a. So k is equal to root a, and that's what we were asked to show. So what's left to do? Oh, we've got to figure out when the two pressures are equal, so when P is equal to A. Now we can do that now because we've got all our constants figured out. We've got 2 root P minus A is equal to negative root A T plus 4 root A. So when P equals A, we have 0 is equal to negative root A T plus 4 root A, which gives me, let's go very slowly, so 4 root A is equal to root A times T. T is equal to 4, so that's after 4 seconds. I think it's seconds. Let's see. Actually doesn't tell us. Okay. T equals 4 then. Now the last thing we have to do is to rearrange it to get an expression for P. So until now we've been able to do everything we need to with this DE without making P the subject. And that's quite often how it works out. But let's do some rearranging. So we've got 2 root P minus A is equal to 4 root A minus root A times T. Now we're trying to get P the subject. This is good practice for the level 3 complex numbers in algebra paper. I'm going to factorise here. I've got root A times 4 minus T. So let's square both sides. Oops, something weird just happened. Okay, so 4 times P minus A is equal to A times 4 minus T squared. P minus A is equal to A over 4 times 4 minus T squared. So P is equal to A plus A over 4 into 4 minus T squared. So all I'm trying to do here is to make P the subject. Now you probably could leave it as that, but it's nicer, I think, to expand out all of it and then clean it up. So we've got A over 4 times, what have we got, 16 minus 8t plus t squared. A plus 4a minus 2at plus a over 4 t squared. Well, there's nothing very lovely about that, but we've got this final equation. So the pressure inside the container is equal to 5 times the pressure outside minus 2at plus this. Okay, so I think it was nice to have it like that, but also it would have been fine to leave it just like that, and that's how the schedule had it. Okay, so two different versions. Right, so that's all for that one. As I said, make sure you do plenty of practice at these. There's some great Delta exercises on DEs, and there are some good Dr. Frost questions that I've just posted on Google Classroom. Thanks for watching.